Hello and welcome to this webinar. My name is Gianpaolo Albanese and I'm a Microsoft Senior Solutions Architect here at AWS. Today we are going to review how we help customers in handling Windows Server end of support challenges with the AWS cloud. In today's agenda, we will review what is Windows Server end of support and why you should care. Why customers select AWS to run their Windows workloads, and how do we help customers in creating a plan to handle EOS situations and dive deep in migration strategies and tooling. Towards the end of this session, we will go through a quick demo of a couple of tools that customers are currently leveraging to deal with EOS. And finally, we will close with a list of additional resources that are available to you. So, what is Windows Server end of support? As a Microsoft Windows Server customer, you are familiar with the pattern of Microsoft regularly sunsetting support and requiring upgrades every few years. The most imminent of these events is the end of support EOS for Windows Server 2012 and 2012 R2 on October 10, 2023. After the date, customers will no longer receive security and non-security updates, bug fixes, free technical support, or online technical content updates. Before you make a decision that could impact your long-term business and operational goals, don't you owe it to yourself and your organization to evaluate potential cloud service providers? This EOS event triggers a comparison between the short-term temporary fixes that are available and the long-term considerations. As you evaluate which cloud service provider to use for your Windows Server workloads, consider how these providers can meet your business needs related to cost, technological innovation, agility, and security. Amazon Web Services and our partners have been focusing on helping customers migrate, upgrade, and modernize their Windows Server workloads with dedicated programs, tools, and technical assistance. Why Windows on AWS? That's a great question. At AWS, we like to say there is no compression algorithm for experience. For Windows workloads, that rings true, as we have the most experience in helping customers successfully migrate and scale their Windows workloads on AWS since 2008, 4 years longer than Azure. Customers choose AWS because we have the most experience with Windows workloads in the cloud, and we offer the best platform for Windows Server and SQL Server for higher performance and reliability, greater security with a suite of identity services, more migration support, the broadest and deepest capabilities, lower cost of ownership, and flexible licensing options. AWS has more experience running Windows Server workloads in the cloud. In fact, it was the first major cloud platform to offer Windows Server instances in 2008. And today, hundreds of thousands of customers across all industries, including Adobe, Autodesk, Capital One, General Electric, Hess, Kaplan, PT Bose, Riot Games, and Siemens, trust AWS to run business-critical Windows workloads such as Exchange, SharePoint, SQL Server, Active Directory, and Microsoft Dynamics. AWS has the largest global reach and the most highly available architecture. Let's talk about AWS regions. A region is made up of multiple physical separate data centers or availability zones that run on distinct power grids to provide a high degree of disaster protection for high availability. We have 31 regions made up of 99 availability zones. AWS is the most secure and leads in the number of certifications. AWS has the broadest and deepest platform. We are continually expanding our services to support virtually any cloud workload and enterprise application. We launched SQL Server 2017 on Linux and .NET Core on Linux in 2018 to make it easier for customers to begin their open source journey. Customers have already used DMS, or our data migration service, to migrate more than 45,000 databases since it launched in March 2016 to move from SQL Server to PostgreSQL on Aurora. And we have reduced our price over 106 times since 2008. At the foundation of every Windows workload is the core platform. Today, we offer over 600 instance types to virtually run all kinds of workloads. It includes general purpose category, wherein each instance type has particular ratio of CPU cores to memory, to compute and memory intensive instances that have their own specific ratio of CPU to memory. Then there are the burstable instances for when customers have very little understanding of how a workload might spike in demand. Further, there are instances with more local storage than any other instance in the cloud. And lastly, there is a category of instances where customer can use accelerators such as a GPU or ASIC, application-specific integrated circuit, for machine learning or graphic-intensive workloads. EC2 offers many firsts and onlys, but I'll just name a few here. There is a choice of AMD, Intel, and AWS designed ARM-based processors, which only AWS offers. The largest memory footprint available in the cloud at 24 terabytes in a single instance. The fastest networking at 400 gigabytes for a single instance. At the center of our rapid innovation and delivery lies the Nitro system, which AWS has built from the ground up to reimagine the virtualization infrastructure. When you combine this efficient compute infrastructure with optimized storage options, you can reduce the need of expensive software licenses and gain high performance. Principal Technologies has tested R5B EC2 instances, which is optimized for memory-intensive application with GP3 EBS volume, and a comparable compute and storage option with another cloud provider to study the performance of these products with SQL Server workloads. In addition to publishing the study results, Principal Technologies has also published step-by-step instructions to replicate the test and validate these results. First, for an I/O-intensive SQL Server workload, R5B 16x large, which is an instance with 64 vCPUs and 512 GB of RAM, with the GP3 storage is 2.7 times faster than a comparable configuration of another cloud provider. Next, they compared the price performance as a ratio of price per 1,000 new orders per minute. To achieve the same performance, the total cost of infrastructure, storage, and licensing on AWS was 68% cheaper. This slide has been used frequently in the past for a good reason. AWS was the first major cloud platform to offer Windows Server instances in 2008. And year over year, we have released exciting services and enhancements based on feedback from our customers. The rate and pace of innovation is eye-popping. In fact, there have been 50 plus new launches in last year alone. Today, enterprises can migrate and innovate even faster thanks to the capabilities we are delivering. I want to spend a minute unpacking this slide to take you through how our journey has evolved over time. The initial focus was on offering the core services, optimized license-included images, managed services such as RDS for SQL Server, Elastic Beanstalk for .NET applications, and directory services for managing Active Directory workloads. As large enterprises have ramped up their adoption of cloud, they wanted to bring their existing licenses. That request led to the launch of Dedicated Host, which is a physical server owned by you, and only instances that you own run on this host. Secondly, customers were struggling to use their existing management tools to manage their cloud environments. That led to the launch of AWS Systems Manager that is now used by a large number of AWS customers to manage all kinds of workloads in AWS. AWS Systems Manager is a great example of how an initiative that started off to meet Windows management needs in the cloud evolved to address a broad set of customer needs. We continue to add a layer of simplification and clarity for Microsoft workloads with services like License Manager. And of course, at AWS, we are focused on accelerating modernization as well. We made recent innovations around Fargate, Babelfish, Porting Assistant, and Microservice Extractor for .NET. You can count on us working back from your challenges and trying to innovate ahead of your needs, and our speed of delivery has only increased. How can we help? There are three phases in our approach to complete large-scale migrations. After going through the process, we continue to assist customers as they start operating and continue to optimize in the cloud. In the first stage, an assessment phase, is where we build a business case and perform a cloud readiness assessment. At this stage, we can help with various programs to build your business case, which we will describe shortly. At the mobilization phase, we build an AWS architecture, create a migration plan, and mobilize businesses to migrate at scale. This is where you can leverage the experience of AWS account teams to bring in experts who either upskill your team or get assistance. And lastly, in the migration modernization phase, we move workloads to AWS, put in place a cloud operating model to run and optimize for further business benefit. We offer tools and partners to help customers achieve their goals. So let's talk briefly on how does AWS help answer some of the migration and modernization questions you might have. One of the ways is by running an optimization and licensing assessment, or OLA. An OLA enables businesses to assess and optimize current on-premises and cloud environments based on actual resources utilization and third-party licensing. This allows you to build a migration and licensing strategies to unlock cost savings as you transition to AWS. By understanding the customer hardware, application performance, and existing contracts, we can provide a solution that will right-size resources, provide a clear AWS roadmap, eliminate costs by using existing investments, and pay only for what you need. OLA is a no-cost offering for new and existing customers. And OLA will provide you with a report that will model your deployment options using existing licensing entitlements or leverage license-included options from AWS. These results can help you explore available cost savings across our flexible licensing options. The OLA is comprised of three steps: data collection with tools like AWS Migration Evaluator or partners. Collecting this valuable data provides the baseline to make recommendations in regards to licensing, right-sizing, and modernization options in the analyze phase. The data analysis is where the tooling makes proven recommendation so that you know what to deploy on AWS. In the planning phase is where now you are empowered to make the necessary decisions to plan your migrations. We have analyzed over 300 OLA engagements, and the data shows how significant the cost of third-party licenses are in cloud migration total cost of ownership. Those are some of these facts. An average of 45% reduction in Microsoft SQL Server licensing compared to the same on-premise IT infrastructure by migrating to the AWS cloud. 60% of organizations who want to migrate their existing enterprise workloads to the public cloud would have to invest in Windows Server and SQL Server licenses if they would lift and shift their current infrastructure. By optimizing right-sizing, 98% of AWS customers can migrate without investments in new licenses. The study shows an average of 77% savings of Windows Server licensing by right-sizing and optimizing on-premises infrastructure while migrating to AWS. Average savings for AWS customers on licensing is 3 times the savings through right-sizing the infrastructure in the cloud, due to large potential reduction in the required CPU cores and SQL Server instances. AWS customers also have flexible licensing options. They can either use our flexible pay-as-you-go option and purchase the Windows licenses with their EC2 instances, or leverage our dedicated host and BYOL for Windows Server, or for customers with licensed mobility products with software assurance, like for example SQL Server, they can bring their licenses to shared tenancy. You can manage your license usage with our AWS License Manager. And we also offer options to use our managed services like SQL on RDS if you desire to remove the burden of administering the infrastructure. Our marketplace offers thousands of options as well if you are looking for specific third-party vendor solutions. Now, let's see how our customers can take full advantage of the cloud. There are three main transformations that take place as customers look to modernize both their legacy Windows applications and databases. First is moving the infrastructure from on premises to cloud infrastructure, often referred to as a lift and shift or rehosting. It is simply migrating existing applications and databases to a cloud server instance. There is no need for code changes, and the customer manages the instance configuration, software, images, and much more. Once you are in the cloud environment, the next transformation is around replatforming the applications and databases into a more automated and managed environment. From an application perspective, that means moving from virtual machines to containers. Containerizing application will help you develop, maintain, and deploy application faster and improve portability. AWS has tools like App2Container to help automate the process of containerizing legacy applications. On a database side, moving from a self-service model to a managed database service like RDS SQL will eliminate the need to do activities such as provisioning, patching, and backup, ultimately freeing up resources for more value-added activities. The third area of transformation is to move from commercial software licensing to open source. Many traditional commercial software vendors have built their businesses around software license agreements that are aimed at locking in customers and using punitive licensing terms to force upgrades and migrations. Oftentimes, commercial software license fees typically add 20 to 50% of cost on top of equivalent open source options. So refactoring your applications and databases to take advantage of open source options can help lower cost, improve performance, and gain access to the latest innovations. These three areas of transformation can be done progressively, in stages, or all at once, depending on the application and database and customer overall readiness to modernize. Now, let's take a deeper dive. What is the typical cloud journey for a customer look like? In the previous slides, we discussed how an OLA can help with the data center discovery of assets, how it can help analyze and inventory data, and build a service map to help find other dependencies required for the server or application. Further, it helps by looking at your licensing and right-sizing requirements to eliminate waste. Once the data is gathered, it is time to create a plan. AWS again can help with various tools, which we'll visit shortly, to create a plan. Or if you wish, you can take advantage of our excellent partners to help with the journey. During the application design phase, we help customers determine application migration patterns, look at the best way to utilize some of the tools that we will describe in a moment to modernize, if possible, their workload. When working with our customers, we make sure to follow best practices and the well-architected framework. At this time, we should be ready to help customers either rehost, replatform, or refactor. In the preview phase, we have determined which migration approach are best suited for the customer workload. And so we're either going to be rehosting, replatform, or refactoring, or a combination of the three. Taking into account the AWS well-architected framework, we redesign the application architecture using best practices. There will be several iterations of this phase, as we see customers always trying to improve on their previous design, trying to move away from clunky, complex architectures and use more cloud-native services. It's a refinement process where the team responsible to execute are acquiring additional skills and further integrating into a new and existing services while validating functionality. In the operate and optimize phase, as the refinement process continues, we help customers by leveraging the use of metrics, both open source or cloud native, to ensure that we are optimizing resources and optimizing and operating the workloads for the best user experience. This is where we come in and provide additional help. Here are some of the tools from AWS and partners to help you along this journey. This is not an exhaustive list. We can help you modernize and migrate your application and service by leveraging any of these services and even integrate with tooling you are already using in your on-prem environment. We also have a program for those edge cases where you can't migrate easily to legacy application issues tied to an end of support operating system. We can help there as well with our EMP or end of support migration program for Windows Server. Let's review briefly another option. Containerizing your application either by refactoring to Linux containers or replatforming to Windows containers by using ECS, EKS, or Fargate is also an option. Let us review how AWS can help you here. We provide different tools to help you modernize your application. In this example, we have app2containers or A2C, which is a command line tool for migrating and modernizing Java and .NET web applications into containers. It allows a developer to discover and analyze the application by creating an inventory of the runtime dependencies, uses the information to extract the application with the dependencies, and create a Docker image. These images can be stored in Amazon Elastic Container Registry, or ECR, and in Amazon AKS, or Elastic Kubernetes Service. The Porting Assistant for .NET is an analysis tool that scans .NET Framework applications and generates a .NET Core compatibility assessment. This helps developers port their application to Linux faster. The tool quickly scans your .NET application to identify any incompatibilities, find known replacements, and generate a detailed assessment, minimize the amount of manual effort needed to modernize the application to Linux. AWS Microservice Extractor for .NET helps customers refactor their monolithic application by helping separating, developing, operating, and scaling application easier by analyzing your code and runtime metrics for parts that can be refactored. Then Microservice Extractor helps the developer by visualizing the application source code so they could see each component, related dependencies, and metrics. Microservice Extractor helps with grouping parts of the application that can be extracted together and finally assists in the refactoring process. The AWS Toolkit for .NET Refactoring is a Visual Studio extension that reduces the time and effort by providing insights and assistance to refactor legacy .NET applications. It assesses the application source code to recommend possible modernization pathways, and it helps with the porting activity. Because you are leveraging Visual Studio, you can validate and test your changes by running your environment in AWS directly from Visual Studio. One of the tools that I like to highlight that customers are leveraging for their migration in AWS is Migration Hub. AWS Migration Hub is designed to be a single location to track the progress of application migrations across AWS and partner solutions. With AWS Migration Hub, you can discover your on-premises portfolio using AWS Application Discovery Service and or import discovery data from your existing sources, such as your CMDB, or from other discovery tools. You can view server information and group servers into applications to plan your migration. You can track the progress of your migration using the migration tools that best fit your needs. AWS Migration Hub can manage migrations in any AWS region that has the necessary migration tools available. AWS Migration Hub itself runs in the US West Oregon region. Migration Hub is available to all AWS customers at no additional charge. You only pay for the cost of the migration tools you use and any resources being consumed on AWS. Migration Hub can automatically tag migrations for cost tracking purposes in AWS Cost Explorer. With AWS Systems Manager Automation, you can easily upgrade your Windows Server EOS to supported version of Windows. We offer several paths. However, to note, that if you are trying to upgrade Windows Server 2008 R2 to Windows greater than 2012 R2, there is a multi-step process that the automation will handle for you. The instance will be first upgraded to Windows 2012 R2 and then upgraded to 2016 and 2019. SSM is available to all customers for free. Now, let's dive into a demo to review these options further. In this demo, we're going to be looking at Migration Hub. Migration Hub is the one destination for helping customers migrate, modernize, and track migration activities. So we're going to look at some of the tooling and also how you can start with Migration Hub. The first thing that we want to look at is the tools that we have available to discover assets in our data center. As you can see here, there is a VM collector that you can deploy to your ESX infrastructure. But what we're going to be focusing on is on the AWS Discovery Agent, which we're going to be downloading and installing into our EC2 instances, as I do not have a data center where I can test this out. We also have a migration evaluator collector where we can then provide the data that we collected and we can send it out to the migration evaluator team to provide some recommendations for us and help us planning a business case. And also we have an import option. So if you do want to just provide a list to Migration Hub, you actually can. You can download this quick template and import that data into Migration Hub. So let's start with the installation of the tool. There's a couple of ways that you can deploy agents. One way you can download the executable for the discovery agent, or you can use the Windows CLI to run a PowerShell command to download and install the agent. For the installation of the agent, you can just click on download for Windows. And if you notice, it will provide you also a command that will help you install the agent. This is very important. You will need to provide an AWS key and a secret key to successfully install the agent and configure it so that it can communicate to Migration Hub. So let me pause here for a second and let me pull one of the instances where we're going to install the agent and show how this is done. Okay, we're back. We are on the remote desktop for Windows Application Server 5. We already copied the discovery agent executable. We're going to open a PowerShell script. Let's change to desktop. And then what we're going to do is we are going to install the agent. And just make a little quick change here. There you go. The agent is installed now on this particular system. So let's go back to Migration Hub and let's wait for the collection of data. And once we are ready, we're going to move on. Okay, we are back in the Migration Hub landing page, and we're now looking at data collector and specifically discovery agent. You're going to notice that all the servers that are basically deploy the agent to, and right now is in the collecting status, and 2 agents are actually reporting healthy. It's going to take a while to collect all the information from the servers, so it's going to probably you're going to have to wait a little bit before you can start using the data that you collected to start assessing, strategizing, orchestrate, and migrate the application. So we're going to wait until this is completed, and then we're going to move on to the next step. So some of the tasks that you can actually run through Migration Hub is to get an EC2 instance recommendation. What you can do is you can either use a discovery tool, which we already done. At this point, you can select a sizing preference, and you have multiple options here. Right now, I'm just using average utilization. Or you can select a percentage, or maybe you have a specific server configuration. Some customers feel like, especially if they're doing a lift and shift, they want to use the same configuration they have on-prem. Our recommended suggestion is always to do either a maximum or average utilization of the system. I'm going to use average. And then you have options to either do shared instances if you're doing a license included, or you can also select dedicated instances and pricing model as well. There are some additional exclusions. So if you like to add additional parameters for the assessment, you can do so. And then what you could do is you can export the recommendation based on the findings. This will take a couple of seconds and we'll be right back. I took the time to clean up the spreadsheet a little bit so that it was a little more understandable. As you can see here, we detected 4 systems during the discovery phase. We detected the operating system that it's running on it. And also we picked up the number of CPUs, logical cores. And the interesting part of this assessment tool is actually a recommendation. It's recommending how much RAM and also that the instance types or model that we should be deploying based on the utilization. Those machines have very low usage, so therefore that's why you have these low numbers here. But again, demonstrates the power of the discovery tool and also in the assessment phase. So let's go to the next step. So we have additional tooling that we can leverage to help us strategize our migrations. In the strategy and orchestrate section, we can collect the necessary information to do an application migration and modernization strategy. There are several recommendations and additional tooling that you can download to scan your environment for specific applications so that we can provide the different methodologies to modernize your application into AWS. And in the orchestrate, it provides additional tooling specifically around migration, either with the lift and shift, or if you have a database that you need to migrate. So this workflow that you can create, which I'm showing right now, it will allow you to either import a virtual machine into your environment, rehost it, or replatform. Again, once you go through these workflows, it will provide some additional plugins that you can download and appliances that you can install on your ESX environment to proceed with the migration. And the last component that I want to show before we go into the dashboard is under the migrate. I already grouped a number of servers and I grouped them under an application. I called it very simply Windows application. But again, here we will allow you to select an update status if you are kicking off the migration. You can also now look at additional tooling. Specifically, if you're going to do a lift and shift or rehost, you can use application migration service. Again, this will allow you to take the VMs that are running in your environment or the on-prem physical servers and do a lift and shift directly into AWS. Or if you are planning to migrate a database, the database migration service will help you migrate your database easily into AWS. And finally, I want to just very quickly look at the dashboard. Here it basically shows the servers that we are collecting data from. It also shows the application of migration status. And finally, it will show you all the applications that are currently targeted for migration. So again, this was a very quick demo to just give you an overview of a migration hub. There is definitely more that's happening here under the cover. If you'd like to know more, please reach out and we'll be very happy to engage with your teams and show you how to use these tools in your environment. Okay, in this demo, we're going to demonstrate how to upgrade a Windows 2012 server to Windows 2019. Some prerequisites. Obviously, you will need an existing EC2 instance that needs to be upgraded. You should have SSM installed and working on the instance. And please note also that TLS 1.2 should be enabled for this automation to work. Another requirement, you'll need at least 20 gigabyte of free space for the installation media. And if the instance is joined to an Active Directory domain, we do recommend that you specify a subnet for the target that does not have connectivity to AD, because during the actual upgrade process, there might be some hostname conflicts that we were trying to avoid. For this to work, you will also need a public subnet with auto-assigned public IPv4 addresses set to true. And this automation will only work for Windows 2008 R2, 2012 R2, Windows 2016 and 2019 servers. Please note that for Windows 2008 R2, the EC2 will be upgraded first to 2012, and then that's going to be a second upgrade to the target operating system, which might be 2016, 2019, or 2022. You will also need an IAM role to be able to talk to Systems Manager so that you can execute the upgrade process on your behalf. This automation, it will allow you to upgrade an instance that does not use AWS provided Windows licenses. However, there are some additional steps that you can find in our documentation. So let's look at my EC2 instance first prior to execute the automation document. And we're going to collect some information as well to help us through the upgrade process. So the instance that I'm actually going to try and upgrade is Windows Application Server 1. Let's connect to this server first. And we're going to connect via RDP. And because I am using a key pair, I'm going to upload my private key and decrypt the password. Copy this password, and if you can have a scratchpad, save this password. We're going to need it to log in to the on the upgraded Windows EC2 instance. So I already have a desktop client created for this, so let's open this up and let's connect to it. So there you go. So you can kind of see it's a Windows Server 2012 R2, and we have a bunch of applications installed on it. So we can close this RDP session. Let's close it. And so the next step is to go to our Systems Manager console. So if you go into search, type Systems Manager, and let's go into the console. What we're going to be focusing on is in the automation section under change management. So click on automation. If you can type clone, press enter key. And we're going to have a few options here. What we're going to be doing is, because I want to show you the different flavors of operating system you can upgrade to, I'm going to select this automation document, clone instance. All right. There are a couple of things that we want to collect. So if you can go back to your EC2 prior to kick this off, there is additional data points that we want to collect. So open a new tab. Let me close this. Let's collect some information from that EC2. Okay. So what we're going to be collecting is the instance ID, so you can copy and paste in your scratchpad. The other item that we want to collect to is also the IAM role. If you notice that it's already set up to connect to SSM, but you want to make sure that whatever IAM role you're going to be using to upgrade or connect to SSM you capture the IAM role. So copy this piece of information as well. And the other item that we need is we need the subnet where this machine is actually set up on, and you want to copy all of this subnet ID. All right. So once you have all that information copied into a scratchpad, right, including the password, let's go back to the system manager documentation. And let's click on execute automation. Okay. I want to bring up a couple of things here. The document description, again, here basically it gives you the different paths for upgrades, right? Read through it. So we're going to pick the Windows OS that we want to upgrade. In this case, is going to be my Windows Application Server 1. The instance profile that I'm going to be using. Now it's time to use your scratchpad. The subnet ID. So I'm going to put in the same subnet as the previous machine. Again, if that machine is joined to Active Directory, to avoid any conflicts, you want to make sure that you select a subnet that does not have AD running on it, and the targeted operating system. So I am going to upgrade to Windows 2019, and we can click on execute. Okay, so it's going to be in progress. These are all the different steps it's going to take. So we're going to leave this console up and running. I'm going to be pausing the video right now. It's going to take about 2 hours to complete, especially for the upgrade. So we'll come back once this is completed. Okay, so after a couple of hours, we can actually look at the execution status of our job, and we can see that everything successfully completed. So at this time, let's go back to the EC2 management console. What you're going to be doing is you're going to be going to the AMI under images, and I already searched for mine, but this is the image that's being created from that upgrade process. So what we're going to be doing is we're going to be selecting this image, and we're going to be launching instance from AMI. All right. So we have some parameters that we need to fill in. So you can name it or not naming the server. At this time, I'm going to name it, and the reason why, so it's easy for us to find it in the EC2 management console. So I'm going to just call it App Server 2019. And if you can see here, this is the AMI that we picked or selected. You have an option here to select also the instance type that you want to apply this image to. So at this time is actually selecting a 1 vCPU, but what I want to do is I want to select a 4 CPU vCPU machine. You don't need a key pair. Remember, we cloned it from our original Windows application server. So hopefully you saved in the scratchpad the password needed to log in. You would have to select the VPC and the subnet. And what I'm going to be doing is I'm going to just allow traffic from my IP address instead. So custom IP, and I'm not going to change anything else, right? So I'm just going to check one more time to make sure I have everything that I need. It seems I do, and let's launch the instance. Oh. I will log in into the machine and see if the upgrade was successful. Okay, we're going to try now and connect to the machine. And if you remember, I asked before about the password, so go back into the scratchpad. I use the same password that we captured from the original system. And let's connect to it, and it should work now. And as you can see, the machine is up. Let's look at the Windows version. And there you go. We have successfully upgraded a Windows 2012 machine to Windows 2019. Okay, after the demos, how can you get started? I mentioned some of the programs during this webinar. And let me offer some additional programs that you can leverage for your Windows workload migration. AWS now offers a program to drive migrations of legacy Windows Server application to the latest supported version of Windows Server without any code changes. We touched upon it briefly. This offering is the End of Support Migration Program, or EMP, for Windows Server that helps customers to mitigate challenges of migrating legacy applications. EMP for Windows Server includes technology and expert guidance to migrate legacy applications from Windows Server 2003, 2008, and 2008 R2, and Windows 2012 R2 to a newer supported version of Windows operating systems without any refactoring. As we discussed, OLA is a key part of the assessment phase to understand how to optimize your environments and licensing usage. And finally, we have a map for Windows, which is built on a three-phase journey to systematically help you accomplish the migration journey. AWS has 60+ partners with Windows workload competencies. They serve AWS customers who seek to select the most qualified partner for deploying Microsoft workloads on AWS. These partners have validated technical capabilities and demonstrated success in helping customers migrate, manage, or deploy Microsoft workloads to AWS. All right, we made it. What's next? Well, first, engage our specialists and partners to explore your Microsoft estate and understand your goal. Second, build a migration case using the OLA to get a full view of your existing licenses, explore options, and evaluate potential areas of savings. Third, engage our migration acceleration experts to discover incentives and accelerate your migration. And lastly, get your first application migrated and start exploring the great things you can do to modernize over time in AWS. Thank you.